All right, welcome. In this, we're going to be going over some basic algebra concepts, and I know that this is a chemistry class, but we still need to be able to solve for algebraic equations. So to give an overview of what algebra is, it's basically when you move around numbers or letters in a mathematical equation. And I could think of 3 steps. So the first one is to solve for an unknown. It must be by itself in the numerator. Let's just go over what numerator and denominator is. So here the a is in the numerator and the b is in the denominator. And whenever you see something by itself, let's say x equals 15, these are both in the numerator. So you could add an over 1 for both of them to show explicitly that they are above the line. They're both in the numerator. But usually people just get rid of that, and it means the same thing. All right, number 2, to get rid of something, you must do the opposite of what it's currently doing. And we'll explain more of that when we get to our examples. And number 3 is subtract is the opposite of add. And divide is the opposite of multiply. All right, so make sure you have a pen and paper ready because I'm going to be asking you to solve for these examples ahead on your own first. So example 1, 3x equals 15. Go ahead and pause this video so that way you could try to solve it on your own. I know you could do it in your head probably, but I need you to work against that and actually solve it. Okay, so 3x equals 15. We're trying to get x by itself. Right now it's being multiplied by 3. In order to get rid of that, we're going to have to do the opposite of multiply by 3, which is divide by 3. And whatever you do on one side, you do on the other. We have the same thing on the top and bottom. You have 3 on top and 3 on the bottom. So we're going to go ahead and cross those out. And we're going to get x equals 15 over 3. And that's just going to equal 5. All right, that wasn't so hard. Example 2. Again, make sure you pause the video and try to solve it on your own. 4 equals 50 divided by x. So here we have x in the denominator. And in order to get that out of the denominator, you're just going to multiply both sides by x. So you see 50 is being divided by x right now. If we go ahead and do multiply by x on both sides, we're going to again have x on the numerator and the denominator on the right side. So those are going to cross out. And then we're going to get x times 4 equals 50. And now we have no x's in the denominator. We moved that out of the denominator into the numerator. Okay, so now we're going to get x by itself. So you could see it's being multiplied by 4. So we're going to go ahead and divide by 4 on both sides and then get x by itself. And that's going to equal 50 divided by 4. And if we want to get a numerical value for that, that's going to be 12.5. But you could just leave it in fraction form if you wanted to. Okay, example number 3. So this time you don't have x as our unknown. Contrary to popular opinion, x is not the only variable that you could have. You could also have different letters like a. So 50 times a minus 3 equals 2. Again, pause the video, work ahead on your own. Okay, so it looks like the first thing that we could do to get a by itself is get rid of the thing that's being added or subtracted by it. So we're going to get rid of this minus 3. So the opposite of subtracting by 3 is adding 3. So we're going to have 50a minus 3 plus 3 to get rid of that. And then whatever you do on one side, you do on the other. So we're going to add 3 to both sides of the equation. Then this is going to cross out because minus 3 plus 3 equals 0. So 50a equals 2 plus 3. That's just going to equal 5. So we have 50a equals 5. Again, we're trying to get a by itself. It's being multiplied by 50 right now, so we're going to go ahead and divide by 50. So we end up with a equals 5 divided by 50. If we simplify that, get it to its lowest form, we could divide both of the numerator and denominator by 5, and that's going to be 1 over 10. Or 0.1. I would accept 1 over 10 or 0.1. All right, fourth example. A, B equals C. Okay, so here now we have absolutely 0 numbers, all letters, and it's asking us to solve for B. It's actually not that difficult. Pretend like they're numbers if that makes it easier for you. But we're trying to get B by itself. Right now it's being multiplied by A. So to get rid of that, we're going to divide by A. Divide by A on both sides. Those two A's cancel out, and then we end up with B equals C divided by A. Not too difficult, I hope. Okay, now this is a tricky one. Example 5, N equals PV divided by RT. You don't need to know exactly what this means right now. We're going to get more into it hopefully later in our chemistry curriculum. It's asking us to solve for t. And now the tricky thing about that is that the t is in the denominator. So we need to get it out of the denominator. If we go back to our example 2, you saw that the thing that we were solving for was also in the denominator. And what we did was we multiplied x on both sides of the equation to get it out of the denominator. So that's actually exactly what we can be doing here. So n equals PV over RT. We could just multiply both sides by t. And again, that t that we're multiplying is on the numerator. Just to show that explicitly, t over 1, t over 1, if that makes it easier for you to understand that this t that we're multiplying is in the numerator, then this t and that t are going to cancel out. All right, then we end up with t over 1 times n equals PV over R. Okay, so anything over 1 is equal to the thing that's on top. So t, I'm just going to write t there instead of t over 1. Now we're really close to getting t by itself. The only thing that's happening to it is that it's being multiplied by the n. So we're going to go ahead and get rid of that n by dividing it on both sides. So divide by n, divide by n, then these n's cancel out, and then we get t equals PV over Rn. And that is the solution.